and welcome to episode 18 of the Offsite podcast, where we chat all things construction and technology. My name's Carlos Cabello.
And I'm Jason Lansini. Good day, Carlos. How are you going?
Livid about this shine down the middle of my head. You can see the light, the lighting set up in this WeWork office. There's going to be a bit of a full egg above here at the moment, which is not cool.
You've self-ball joked yourself. Cool.
Yeah, I'd rather self-ball joke than you say it. It makes me feel a bit better.
Okay, cool. How are you doing? Yeah, I'm good. We, as you know, we've got a couple of new starters joining the team here. And one of the things that we do whenever we post a job listing is we have like a bunch of questions. And one of them is to tell us a one-liner that we wouldn't have seen on like the first page of Google. Yeah. And there's one that I saw the other day when we were reviewing candidates that's had me like laughing whenever I think about it. So I'm actually going to turn up with a one-liner. And it's, we can drink 10 liters of petrol and live, to tell the tale. Jerry can. Yeah.
Nice.
That's good.
That's pretty good, actually. And the broad range of one-liners that we've had over the years, that's definitely one of the better ones.
Yeah, with half of them you couldn't. Yeah, you would get like an explicit warning on the podcast.
Absolutely.
Cool. Today we have a couple of guests joining us, Carlos. And I guess the context in prior weeks, you know, we spoke about, I guess you'd call it like non-traditional planning or things that are like programmatically generating schedules or maybe different use cases for AI. And this was triggered off the back of, I think you saw a demo of Alice being used on a section of the High Speed 2 project over there in the UK. So today, I guess, Peter Rautenbach and Pat Banks, and they work for, let's say, a kind of skunk works within Deswik. So Deswik's like a very successful mining software company, and they've got a ton of smarts around things like optimized mine planning and mass haul routes. And so I guess I thought I'd ask Pat and Peter to join us. Peter, Pat, hello, welcome. Thanks for staying up.
Yeah, Matt.
Thanks for inviting us.
Peter, your LinkedIn, I've never scrolled for so long on a LinkedIn page before. There's a lot going on. RICS, South African Council of QSs, Engineers Without Borders. You speak 4 languages, Deja Awards. You've got courses in yoga, in Python, in
Jeez, I
contract
don't
law.
even know the yoga.
There's everything on there. So it's like, oh shit, where do I start here? You started as a QS. You then had quite a big focus on BIM. How did you tie those two together? What was the transition?
Oh, you just got me thinking about the yoga, actually. But we'll get into that one another day. It actually starts with the yoga. I
want to hear this now.
Yeah.
You want to see proof as well. Show us.
I was working in Australia. I was working for a mining company, and I got married, and my wife and I were like, "Oh, let's go traveling for a year before, you know, life gets too serious." So we went traveling for a year, and we started with a yoga course in Dresden, which I thought would be easy, but it ended up being really intense. It was this like master yoga teacher called Nikki Knopf, who just like, I've never done anything so hard in my life. But it was quite good, and that was the start of it. And anyway, after the yoga course and the traveling for a year, I came back to Australia, and I didn't have work, and I ended up getting a job with a contractor in central Queensland, doing a 10 on 4 or 5 roster as their commercial manager, and it was a really tough job. And it was just claims every day, and it was, you know, it was rough as guts, and it was war. And I was putting in all these claims, and often you have to show extension of time in your claims, and causation and all of that. And they would just look at my V6 schedules and Excel and say, "So what? Go away." And then one of the engineers on our side was pretty good at 3D models and Navisworks, and we started time-lapsing what had happened with access issues and stuff. And then suddenly I started winning these claims, which was good. So we got some money, but then also the fitters on site and the electricians, and they got really interested in these models, and they'd be sitting in my side office in the mornings being like, "Hey, can we get access there?" And the electrician would be like, "No, forget that. You're not going in there. We're in there today." And I was like, "Oh, this is magic. Somebody's actually listening to a plan for once," And I was actually struggling with the claims because we never did what we said we were going to do. So it's hard to justify a claim when I won't say which job it was, but it was great that we were actually following the plan, but it was all visual based. So I got really into BIM through that, and thought, I really like how we can use models to plan our work, and then learned a bit of 4D planning, and got into that a bit, and then I was at a conference and I saw this guy doing a talk. His name's John Merchant, and he was talking while he was talking, he was coding this bridge, and I was sitting there and my mouth just dropped, because it was the first time I saw generative design, or and he was using Grasshopper, and he would say, make 3 columns and design this bridge, and this bridge was getting designed in front of us. So I was like, wow, this is really blowing my mind. So I went and had a chat with him afterwards, and I was like, you reckon we could build a schedule using this? And then John and I spent quite a lot of time building it was a structural little building, and we designed it programmatically, and then we wrote a program to design the schedule, and then it got built through the schedule, and we visualized it. It was really cool. But it was useless because it had no resources or anything like that.
If you use
That's
AI
the
to
usual
build,
schedule, Peter.
if you're using AI to design something with schedule in mind, is it like a schedule optimized design? Do you know what I mean? So you can ask it to make it the most efficient design based on program.
Yeah.
Is that
None of this was AI. This was all just
right?
coding, where you give a
Right,
computer a parameter and say, I want you to build a building for me with so many stories, and then it designs it for you. But it's no,
Right.
you don't actually have to draw a line, And the same way
Yeah.
with the scheduling, you don't have to type a task. You just say, if the task is concrete, order concrete. And if the cubic meters are 30 cubic meters, give it this duration. And if it's on level 2, make sure everything on level 1 is done. And so you're just giving it rules, and it's fits on a schedule. So it's not AI, it's rule based. Yeah, so that's how I got into BIM. And then I met Deswik, and I was like, what? You guys do this for real life? Yeah, that's how I've ended up doing this now.
Nice. And you still do the yoga?
I do. I'm not nearly as good as I used to be. I only do like 15 minutes, but yeah, I do a little bit of it. Pat and I go for runs twice a week usually. So
Nice.
yeah.
Very nice. I think the main takeaway for me there was I used to have a construction director on a project when I worked in London, and sometimes we would have a little complaint about the quantity surveyors, and he always say like, where are we getting these quantity surveyors? Are we just getting them off the street? And now I know that we're just getting them off yoga retreats in Dresden, and that's where they're coming from.
We haven't done one episode where Jason hasn't poked fun at a QS.
No, that's it. I got it in there. So I guess to kick off, Peter, and maybe to set the scene, like we've talked a number of times before about the idea of generating schedules, and that for some types of projects, traditional planning methods of like building steps up and then linking them together don't drive like the optimal results. And, we talked about the use case of earthworks, where in my experience, mass haul plans would, the development involved a supervisor getting in a car, driving around a site, smoking a few cigarettes and saying, okay, here's the mass haul plan. So I guess to maybe set the scene and give some a way to get into the context of a use case. If we were to focus on earthworks, tell us like what you see at Deswik as how mass haul planning looks today, and then what it can be.
I guess, to set the context, we didn't start realizing what a problem mass haul was until we got to site with our clients. To be honest, it wasn't the first thing that we approached, and because it's a little bit different in construction to mining as well. It's quite intricate in construction compared to mining. I guess Pat can jump in there. But what we found is that we often find that there's a problem with quantifying the job as a start. Like a lot of our clients, the supervisors and engineers on site aren't aware of what their current quantities are. So we help them achieve that first on site by actually taking the design model using the drone scan of the site, turning that drone scan into a surface, and then we could chop up where the work was done to and where the work was supposed to get to. And the difference would be your remaining work, and the opposite obviously would fill. So we're able to build these pretty cool, reports effectively. Just and it's basic stuff. The engineer would be like, thank you, I finally got some quantities. And and then those quantities were cut up by different material types. So you had a better idea of what you could do. But then very quickly, the mass haul problem came after that, because what we were finding is that it's done in Excel. It's really slow. People, they sit there with this sheet, and if it's a big job, hundreds of rows and hundreds of columns of the same thing, and they're trying to make it go from top left to bottom right, because theoretically that should be the least haul, but then they're going to get stuck because I've already filled that fill with other dirt, and they're like, oh damn, where am I going to find like some cuts for this fill, or the opposite, and then you got to start again. It was quite a painful process. And I guess what we found was that they often mass haul doesn't get done a lot on projects by our clients, and it kind of ends up being the supervisor driving around doing it on the back of the cigarette box or in PowerPoint. So so that was kind of the how we got there and how we solved it. And in mining, we do solve similar problems, but this one was a little bit unique. And Pat can probably talk about that because he wrote a lot of the code.
Yeah, well, basically what we do in mining is it's a slightly different problem, because you've got a lot of materials in a tight space that very constrained by what you call your cut shed, where you've got to dig it up because you're digging up something that's valuable, and then you've got to put it somewhere because you're dumping your waste somewhere, and you might have to be careful about your waste materials because they might be acid forming, need capping or something like that. But it's very constrained on the cut schedule, which is in mining, the mining schedule, where you're targeting valuable material to send to market on a ship. But when we get to the mass haul problem in civil, it's not driven so much by that, but more by practicality. And what we were able to do is take some optimization knowledge we have on a differently framed scheduling problem, and then pull it back out, take the time element out of it, and more optimize where material goes in a global scale, and then start scheduling at that point, because that more suits a surface-based, infrastructure-based problem.
It's super interesting. I've not really thought of it like that. So I guess if I was to try and state back to you, what you're saying is like in a mining scenario, you've got this cut schedule where you're constrained by what you've got, like more fixed constraints on this material ends up here, this material ends up here, this material ends up here. But in the construction scenario, you've got it's coming from here, it needs to go here, but you're almost like balancing. You've got more unknowns, maybe. Is that
Yeah, well, they're different unknowns. And the constraints in mining are a lot of vertical stacking constraints, where you're digging, say, a medium-sized open pit might be a couple of 100 meters deep, and you've got 10-meter benches. So you've got a couple of dozen benches that you have to basically take off one at a time, with maybe a one or two bench overlap. You might have 3 open benches at once. But when you're looking at a big surface infrastructure problem, you've only got 1 or 2 materials, maybe 3 materials ever open at once. And you can do this over the whole area of the project, whatever timing suits your plan, your optimal distribution of resources. You're not as constrained as mining. So we reversed the mining problem, and we said, well, what would we do if we could get access to all these surface areas at once and try and distribute materially more cost effectively?
Yeah, so that like lack of those constraints, so that you could almost start anywhere and it's not stuff stuck beneath other stuff, means
not as much.
Not as much, but the problem's almost like harder to solve for a human, because there's like infinite number of ways that you could try and like solve the Rubik's Cube and find.
Yeah.
And we've actually got an algorithm that what it's built to solve, and again, in fact, just jump in here because you've done a lot more of this than I have, but you cut the schedule, and then it says, where's the best place to place the stuff that I've just cut. Whereas, and that's been in Deswik for years. It's automated scheduling.
Yeah, it's
Programmatic
a
scheduling.
greedy algorithm, is a technical term for it. It's something that just solves
That's what I call
what's
Carlos
right in front
sometimes.
of it.
Yeah. But then we actually found that was very similar to the human behavior that we were seeing on site as well.
Exactly.
They were
Yeah,
just
the
dumping shots.
supervisor driving around in utes doing the same thing. It's like, how can I get out of this shift and just get to the next one?
Yeah.
So that wasn't actually solving the problem. So we almost had to build a middle stage where the engineer can say, firstly, I just want to cut and fill between this and this area because this is a separable portion and I need to finish this first. And this type of material can go there. And then we let the algorithm solve it. So we've almost had to bring a little bit more human intervention into it.
So you can apply some more like upfront constraints that sort of reduce the problem set a little bit, or like apply more rules to it.
Yeah.
So Peter, right at the start, you mentioned that like this mass haul planning, like given it's done in a spreadsheet, it's really time consuming and difficult for an engineer to do. They have to go through iterative process in a spreadsheet. Therefore, I imagine with my engineer hat on that I probably want to do that the least number of times possible. As the project starts, as like construction starts, dirt starts getting moved around, things happen, delays happen. We find rock where we didn't expect rock. We find issues where we didn't expect issues. So many times on previous projects, similar to the original mass haul plan, the supervisor drives around a bit and goes, here's the new mass haul plan to work around this problem. Is what you're doing with clients, like helping them typically at the tender stage, at like the pre-construction stage, or is it throughout the construction phase? Because it would definitely be something valuable then as well.
Yeah, we work with different clients, different phases. We're working with an owner at the moment, pre-engineering even, on one of our projects. So that's cool. And in mining, traditionally we start quite early, but because in construction we don't really have a name and nobody has money in the pre-construction phase, we've kind of had to start at the back and earn our keep, so to speak. So we started off right at this back when they were like, oh, we don't know what's happening with this job anymore. Can you just help us get some quantities? We started with doing the drone flights. Our first job was effectively that, so that they could get paid. This is how much type of this dirt you've cut this month. Put that into your progress plan. And then we were like, hey, do a little bit of planning off of that. But like, that's kind of where we started. We're trying to get through the life cycle now, because the earlier you are, you can really make those decisions that can have a big impact.
I'd imagine like at that tender phase for sure, and immediately following, you can have a massive impact. The right mass haul plan.
Yeah, but so then but to answer your question, yes. So and that's not our technology. We use other tools that do the flyover and processing of the drone technology. We just import that usually as a LAS file, and then bring it into our software. But that's really enabled something very powerful for us, because you can effectively do a full update of your schedule at 10-meter changes to the quite accurate, and do a progress update. But then you can plan off the remaining works with the same algorithm you previously had very quickly, in minutes.
So you build a plan, it will be able to progress it, I guess, really quickly, and then adjust the remaining plan based on where progress is at.
And most of our clients aren't quite there, but if you are tracking your productivity of your fleets and your vehicles, you can adjust your resourcing productivity rates as well. So you can get a more accurate view of what you are going to do in the next few weeks.
Yeah. Cool. Sorry, I've hogged all the questions. Carlos, do you have anything you'd like to ask the gentleman?
I'm going to caveat this with I've never experienced a mining project, so apologies if my questions are like oversimplified.
I thought you were going to caveat it with I'm a quantity surveyor, but I think by now that's sufficiently.
Nah, that's not a warning. That's like what's the opposite of a warning? I want to sort of focus on, so obviously the haulage aspect. You mentioned optimization. With my QS hat on, obviously you focused on the optimization being like location-based automation, how much in terms of, if you think about what is optimal, do you think about like cost and then maybe think about carbon based on, I don't know, distances that vehicles are moving and things like that?
Yeah. Oh, it's an excellent question. If I can take this one, Pete.
I'll let you take the question, but I just want to say something as well, which is
All
very
right,
important.
you can be my filter again.
I'm also a quantity surveyor.
I know. My next questions are very much focused on that.
I wasn't going to say anything.
Yeah.
I did my research before. I'm coming back to that, Peter. But yeah, Pat, obviously.
Okay, in terms of optimization, like we've got a lot of history optimizing things, and we've had plenty of discussions about what the word optimal even means. But in a mathematical term, it means you cannot do better. And what we're doing at the moment, mathematically, in this skunkworks, as we've mentioned before, is getting the minimum possible combination of distance moved by volume. So at the moment, that's what we're optimizing. But what some of our other tools in mining that work in a different space in the mining scheduling, so that the stuff that is more based on the schedule and the excavation of benches and time periods, that looks at a few more parameters. So instead of multiplying distance by volume, they are multiplying fuel burn, cycle time, anything that contributes to your cost. So we're at the point of bringing those parameters into this approach to it at the moment. So we're going to be doing the same thing. So we can calculate the fuel burn of a particular route based on its change in gradient, its distance, the rim pull of the truck, the fuel consumption of the truck. And we can calculate that for any given haul. So if we plug that in the same algorithm, we can then optimize for the minimum total fuel burn for any given scenario. And that's what we're working towards. We don't have it yet, but it's not far off. So
To double click, and sorry to jump in on top of your cards, but it's super interesting, Pat. So what does that actually look like in terms of the setup for in the mining scenario? Do you define the like fleet going in, or is the fleet
Yes.
sort of emergent thing? Okay.
So you need to know the trucks that you're using, and you need to know their fuel consumption, their capacity, all of those bits and pieces that tell you how much fuel you're burning to move a cubic meter of material from point A to point B.
Okay.
And we get that from the manufacturers. We get that from site records, calibration, GPS tracking. If we can clean that all up and say, okay, we can now confidently say that moving here to here along this route will burn this much fuel, then we can plug that in and say, well, this is how to burn the least amount of fuel possible.
Yeah, that's super cool. And does that work across like a mixed fleet that might have like scrapers and stuff in it as well?
Yeah. Yep.
Yeah.
Wow, that's cool.
Maybe just we usually just start with the CAT handbook because it's quite readily available. But then go for a Pat.
Pat doesn't believe the numbers in the CAT handbook is what
I don't believe the numbers in the CAT handbook. I think they're a bit optimistic. So that's why we then go back to site records and we calibrate on what actually happens.
But I was also going to say our mining business is looking very heavily at electrification now, both electrified trucks or trolley assisted trucks. So, they're spending a lot of time on understanding that and developing technology to plan that better as well.
There's even some battery trolley charging, so charge on the fly trolley trucks being worked on at the moment.
Peter, do you see in any of the like construction clients that you talk to any real interest movement in any electrification of fleet for either on the biggest of projects?
I haven't seen anything on electrification of fleets on the infrastructure projects, to be honest. But I have had questions about carbon. I'm not sure if, we're just missing it over here, but generally what I've seen is people just like reconciling fuel slips to try and report on carbon, but I haven't actually seen much carbon planning in the civil space, to be honest. And I've heard of people talk about, using your cubic meters of dirt to do your carbon planning, which I guess is a start, but ultimately, I think your mass all drives it, because it's the distance and the volumes that those trucks move, and the gradients that they move them on, that's going to drive your carbon on a civil job.
Yeah, Carlos, just jumping back to you, because I know we've spoken about this before, and I think you were going to ask a question about carbon as well, because there's a lot of emphasis over there in the UK about planning for carbon and considering carbon in decisions about projects.
And I actually had a conversation with a guy who got funding for a company that claims they can retrofit batteries to these large haulage mining trucks. So he claimed it was the next wild thing. We'll see what happens to that soon. But that completely changes your drivers then, right? Because if suddenly fuel isn't the issue, you can completely spin the other two parameters, which is cost of program, and drive it in a completely different direction if doing double the distance in a truck no longer has a negative effect to an extent. You can then completely optimize in a different way.
Yeah, definitely. Just on that point that you said, I said that I haven't seen much of real electrification stuff on the infrastructure side, but I have seen a lot of that in mining.
Yeah, there seems to be, particularly on the major schemes here, there's quite substantial use of like electric fleet and everything like that, which is good.
Cool. Conscious of time, so thank you very much, guys, for joining us, and thank you everyone for listening.